Hello Matrix and welcome again. Today we are carrying on with functions and we're looking at hyperbola functions. Now, the key to understanding hyperbola functions is just to know what a normal hyperbola function would look like and then how that would change based on the numbers that you are given. So let's look at, in pink, I've drawn a normal sort of hyperbola function. And this is the general form. So y equals a over x minus p plus q. So depending on a, p, and q, this can change. Now let's look at a. So that's the number on top. Well, I've just put here y equals a over x because a can be kind of any number. But if it was negative, our hyperbola would look like this. Okay, it would be in the other quadrants. Okay. So this is equal to, this would be, say, y equals minus a over x. Okay, now the next thing we look at is the p. So p is sitting with the x, which means it's a left and right shift. So negative p, so we know with x, if it's minus p, minus, it shifts it forward. It's counterintuitive. And if it's plus p, it shifts it backwards. So if p was positive, it would be over here somewhere. And if p was a negative value, it would shift it that way. So these hyperbolas have asymptotes, and this p is actually the asymptote. So in the normal graph, where I haven't changed anything, I have an asymptote of x equals 0. Okay, but the asymptote is actually x equals p. So whatever p is, that's the asymptote. Okay, now remember it's negative p. So if you had negative 1, your asymptote is 1. If you had plus 1, your asymptote is negative 1. With q, it's simple. It's an up and down shift because that belongs to the y. So as we can see, if q goes up, y goes up, so it's up and down. So we have an asymptote of y equals q. And at this point here, it's obviously y equals 0. Okay, so that's the general form of the equation. Now, what I want to do, even though there's not a question in this paper on the what we call the axis of symmetry, this is important. And so when you want to find your axis of symmetry, all you do, and I'm going to do another video on this, is you kind of think of it as this thing here. So you just imagine that that's your axis of symmetry. Now I'll show you how this works. Because there's always two axes of symmetry. There's going to be that one there, and there's going to be that one there. So our axis of symmetry, what you do is you write that out. So it'll be y equals, and this, whatever this is, you just write it out as. So it'll be x minus p plus q. You just write it like that. And then all you do is you put a bracket over here and over here, and you say plus or minus. And that will give you your axis of symmetry. So what I'm going to do is probably for this question, actually do the axis of symmetry, even though it wasn't a question. So we'll make that 4.6 so that you can see. All right, so hopefully you understand the hyperbola. Now, as always, I've got an exam question because this is really what tests whether you do or don't understand it, because it's easy when you look at this. You might get it, but then suddenly you get a question in the exam and it's like, what is going on? So let's have a look. What is going on? So we've got a g of x, which we can see is a hyperbola function. We've got an intercept there of 3. We've got these asymptotes, so they've told us the asymptote. So this one is we can actually probably just write it down. So here we've got an asymptote of x equals minus 1. And here we've got an asymptote of y equals 1. So they've told us that we've got a y-intercept, and we've also got another graph here, which is y equals x. So they've actually got this. Now, y equals x is actually the axis of symmetry of a normal hyperbola if you didn't change anything. But this is not a normal one. We can see this is shifted. Okay, so they want us to want to know what P and Q is for the first question, 4.1. Okay, well, we can see that P is the asymptote, and we see that P is -1. So P is not going to be -1, it's going to be P is equal to 1. Because x plus 1 will shift it backwards by 1. So P is not -1, it's 1. Remember, it's x minus P. So that can be confusing. Q, don't worry. So Q, if it's 1, Q is 1. So with P, we just have to remember to change the sign. Now, if this had been x minus P over here, P would actually be -1 because it would be -1. So careful, they sometimes are sneaky. And when they write x plus P, like they have done, they can sometimes write x minus P, which is the standard form. And then you would have to, again, just make sure you get the sign right. Calculate the coordinates of t. Well, t is the x-intercept. So that's where y equals 0. So we can just make, now that we know the standard form of the equation, or the form of the, not the standard form, the equation of g of x. So we know that g of x is equal to 2 over x plus 1 plus 1. And we substitute in, because it's the x-intercept, 0 for y. So 0 equals 2 over x plus 1 plus 1. Take the 1 over, becomes -1 equals 2 over x plus 1. Okay, so we could times through by x plus 1 on both sides. So it becomes minus x minus 1 equals 2 minus x equals 3. So therefore x is equal to -3. Okay, they want the coordinates of t. So I don't want to run out of space. Well, actually, no, I should be fine. I'm just going to say t is -3 and 0. Okay, 4.3 says, I'm going to leave that space there where I'm going to do the axis of symmetries. 4.3, h of x equals gx plus 5. Write down the vertical asymptote of the graph of h of g of x plus 5. So what does that mean? So that means g of x plus 5. So it means add 5 to x. So what happens if we add 5? When we add 5 to x, we shift it backwards by 5. So it goes from -1 all the way back by 5. So it actually becomes x equals -6. Okay, now they want the value of OS. So let's do that here. So we'll do 4.5 over here. So OS, we need the distance here. So, well, we know O is 0 and 0. This point here, we need to work out S. Now we're going to get two values for when we try and work it out. We're going to get this value here and this value here, because what we want to do is we want to make the two graphs, y equals x, and this graph here, this parabola, equal. Okay, so y equals x is just x. So let's say that we made them equal. We would say kind of g of x equals, and that's y equals x. So g of x equals y, so the straight line. So what we're saying is we're going to make, let's just put that up there, 2 over x plus 1 equals x, because y is equal to x. Okay, now we take the 1 across, so we're going to get 2 over x plus 1 equals x minus 1. X minus 1. And let's just multiply both sides by x plus 1. X will multiply, yeah, so that we get rid of this x plus 1. So it becomes 2 over, and we times that by x plus 1, so it's just 2 equals, and this becomes x minus 1, x plus 1. And so we get x squared minus 1 minus 1. That goes across and becomes minus 3. So take this 2 across, or let's put it there. So for now, so we'll say 0 equals x squared minus 3. Okay, so basically what we have is, then if we factorize this again, we'll have 0 equals x minus 3. Actually, it's not difference of cubes. It's plus or minus root 3. So we'll say x squared equals 3. So therefore, x is equal to the square root of 3. Okay, so well, we know that y is equal to x, so then we don't know y is also equal to the square root of 3. So if I was to do a little triangle here, this is then going to be root 3. This is going to be root 3. And so this line is just root 3 squared, which is just 3. It's not, it's what they want, the length of OS. Okay, so it's actually, it's not, it's going to be, so OS is equal to, it's going to be the root 3 squared. So this is actually OS squared because it's a Pythagoras, plus root 3 squared, okay. So then OS is equal to, when we square that, it becomes 3 plus 3 is 6. And so OS is equal to the square root of 6. Okay, so that is 4.4. There is a 4.5 as well. It says, for which values of k will the equation g of x equals x plus k have 2 real roots that are opposite signs? So what are they saying? So g of x is this hyperbola. And they're saying if you plus k, so in other words, if you shift it by k, when will it have 2 real roots? Well, that have opposite signs. Well, let's look at the g of x equals x plus k. So this is the line of x plus k. So they're saying if I was to shift this graph up by k, so they're not actually shifting the hyperbola, they're shifting the straight line. Well, at the moment, it's got roots here and here, which is both one's positive, one's negative. If I was to shift it up to here, so say it went to here, at this point here, we would start to have 2 negative roots, because this would be this is always negative. But if we shifted it up to here, we would have a negative root, because this is over here, so this side here are positive. And let's do negative in blue, so that we just see, so that maybe that makes a bit more sense. So at the moment, can you see that it's the straight line is still red and touching through red, and then this is red this side. Now, if you move it up further, so if I was to move the line up further, so let's say I moved it up here, you can see that it's touching the hyperbola both on the blue side of the graph, not on the red side, the positive side. So it would have two positive real roots. So basically, we can't shift it up by more than 3. So x must be less than 3 and equal to 3, because 0 is a positive number. So it must be less than 3. K must be less than 3. Okay, so 4.4, K is less than 3. Okay, any value down here, that's fine. If you take it down, if it was minus 100, you're always going to get positive on that side. And this is always negative on this side, as long as you're shifting it downwards. It's only when you shift it upwards that you see that you get the positive happening. Okay, so that was 4.5. Okay, now what I want to do quickly is just do the axis of symmetry. So they could say, what is, so 4.6, let's make our own question, 4.6, what are the axes of symmetry? So sometimes they just want 1. And so they'll say, what is the axis of symmetry with a positive gradient? So that would be this one. If we're dealing with here, the negative gradient would be this one here. So let's just get both. What are the axes of symmetry? It's not a common question, but a lot of people don't get taught this axis of symmetry equation. It's really easy. So what I'm going to say is, this is the equation here. So I'm going to do this question in yellow because we did it up here in yellow too. So it was, there is the axis of symmetry. So what I do is I'll say, right, the axis of symmetry is y equals, and I'll say x plus 1 plus 1. So it's kind of like that, but then I just put the brackets over here because whatever was under here gets a bracket when I do it, and then I say plus or minus. So it's just like this. So you just do this. The bit under the line gets a bracket, and then I just put plus or minus in front of that. And so then y is equal to, okay, so the positive is going to be x plus 2, and the negative is going to be y equals negative minus x, and then minus 1 plus 1. So it's going to be minus x. Okay, so let's just draw those on there and see what we get. So this is the y equals minus x, and we see, yes, that is indeed the axis of symmetry. So that would be the axis of symmetry with a negative gradient. And the other axis of symmetry is x plus 2. So this is the line over x plus 2, or y equals x. X plus 2 would be shifted up by 1. So that would be there. And we can see that the axis of symmetry always go through the points at where the asymptotes meet. And we see that point there. So do you see this? You see, let me draw it. See this asymptote here, y equals 1, and this asymptote x equals minus 1. They meet over here. And that's also where the axis of symmetry meet. Okay, so that's hyperbola. Pretty much all you need to know is in this video. And we'll do some past papers and so just to solidify that knowledge. And yeah, we're going to finish off with log functions in the next video, and then we are done with functions. Well, we're done with these functions. There'll still be some calculus and trig functions. But yeah, we're done with the functions section of paper 1 after the next video. So hopefully that helped. If it did, find the like and subscribe button down below and click it. Share with all your friends, support the channel, and I'll keep helping you guys out. So yeah, see you again for the next lesson.